So one of the first things we want to understand in physics is how to describe motion in one dimension. And we're going to start off understanding this by understanding the concept of length, with the goal being to really understand this plot over here, this plot of position versus time, and what it tells us. So when we're describing lengths, we usually measure these in SI units that are appropriate to measuring distances. So we would use units of meters, or some variation of that comes along with a prefix, something like this graph over here, which shows us kilometers, right? So that's 10 to the third, and we should start to get familiar with those kinds of prefixes. Now, in terms of length, we're usually trying to measure a couple of different things. We might be trying to measure a position, so that's measuring where something is. If I'm measuring a horizontal position, we'd usually use the letter X to represent that we're measuring horizontally. And if I want to measure a vertical position, we'd usually use the letter Y to denote that something's vertical. And we can measure these positions which tell us where something is. But we want motion typically in physics, so typically we're measuring a change in position, which is also known as a displacement. We want dynamic motion. We don't want just static things. So this is how you find a change in position. And in physics, we have a Greek letter that we usually use to denote that something is a change. We use the Greek letter delta, which just looks like a triangle. So if I want the change in position horizontally, that would be a delta X. Change in position vertically, that would be something like a delta Y. These are both ways that we can measure a change in position, and they are equal to some final position, so some final X minus some initial X. We denote X initial with the X0, where this 0 represents naught. X naught. Okay, or Y position would be Y final minus Y initial. Okay, so we can measure these changes in position. So what does this look like in kind of a plot, in kind of graphical form? Well, first, to figure this out, we need to draw a reference frame. So we're going to draw a reference frame that is just a coordinate axis. We have a y-axis and we have an x-axis. Y-axis, we can also use the unit vector j hat, and x-axis, we can also use the unit vector I hat. And if I want to measure a change in position, what does this represent graphically? Well, first, again, as I said, we start with a reference frame. That's going to be typically the x and y axes. And drawing these pictures is kind of a good way to start trying to solve some physics problems. I can denote some different positions. I could denote the position x1, let me say, is equal to 2. So I'm going to have x1 equals 2, and I'm going to have a position x2 equal to negative 2. And these are both positions. Okay, so x1 is at the position 2. If I want to know the change in x1, then I have to measure it with respect to some starting point. And let's say we start at the origin, we start at the position 0, and let's draw a vector that gets us to x2. So I start at 0 and I get to x2. To figure out the size of that vector displacement, I can do the final position of 2 minus the initial position of 0, and that gives me that x1 is equal to 2. Now I can take this position that I'm at, this x2, and I can imagine walking along a line to get to the second point, to that second position, negative x2. So I want to know how big is that? Well, I know x2 is at the position negative 2, and the displacement, delta x2, is equal to the final position, which is negative 2, minus the initial position. Except now, instead of starting at the origin, I'm starting where x1 is. So that's going to be a starting position of 2. And I do this delta x2, the displacement for x2 from its origin, from our starting point, is negative 4. And right now these numbers are meaningless, so what we need to do, we need to associate some kind of distance, some kind of unit with this. So I'm going to say that these axes are both measured in meters so that we can attach some physical meaning to these numbers and get these displacements in terms of meters. So how far did I actually travel? Okay, what's my total displacement? So if I want to know my total displacement, let's say delta x total, I can sum up my individual displacements. So I can do delta x1 plus delta x2, and that'll give me my total displacement from the origin that I started with, from the very central 0 point. So delta x total has got to be equal to delta x1, which is 2 meters, plus delta x2, which is negative 4 meters. So my total displacement from the place that I started from, the very initial position, is 2 plus negative 4, which is negative 2 meters. Okay. So what that tells us is that negative tells us our direction, because this displacement is a vector. The negative 2 tells us we're going backwards, so we're going along the negative x-axis. And then the 2 tells us the magnitude. So I walked backwards a span of 2 total meters from my initial starting point. Okay. So that's how I can figure out my displacement relative to my start. But what we can also do is figure out what is the distance that we've traveled. The distance that I traveled is equal to some x total. So notice that there is not a delta, not a change. Okay, so that means that I want the total value of this. To get the total value, so how far I've actually walked, I need to account for both paths. So I need to find the total displacement of x1 and take the absolute value of that, because that's how far I've moved. And I need to add on delta x2, but I need to take the absolute value because this distance is a scalar. It only cares about magnitude, it doesn't care about directions. So this x total is now going to be equal to delta x1, which is 2 meters, the absolute value of that, plus delta x2, the absolute value of negative 4 meters. I take the absolute value, that gives me a positive, and I get 2 plus 4 equals 6. So the total distance that I walked is equal to 6 meters, even though my total displacement from the starting point was equal to negative 2. So that is distance and displacement.